The metallurgy of iron. Iron exists in Earth's crust in many different minerals, such as iron pyrite, citrite, hematite, and magnetite. Hematite and magnetite are predominantly suitable for the extraction of iron. The metallurgical processing of iron involves the chemical reduction of the minerals by carbon in a blast furnace. The concentrated iron ore, limestone, and coke are fed into the furnace from the top. A blast of hot air is forced up to the furnace from the bottom. That's why it is called a blast furnace. The oxygen gas reacts with the carbon in the coke to form mostly carbon monoxide and some carbon dioxide. These reactions are highly exothermic, and as the hot carbon monoxide and carbon dioxide gases rise, they react with the iron oxides in different temperature zones. As shown in Figure 1, the key steps in the extraction of iron are the decomposition of the limestone in the furnace is shown in the equation below. Limestone to calcium oxide and carbon dioxide. The calcium oxide then reacts with the impurities in the iron, which are mostly sand, and aluminum oxide. Calcium oxide, the silicon dioxide to calcium silicate. A mixture of calcium silicate and calcium aluminate that remains molten at the furnace temperature is known as slag. By the time the ore works its way down to the bottom of the furnace, most of it has already been reduced to iron. This image is what we call the blast furnace. So we can see at the top, the iron ore, limestone, and coke. Iron is obtained from the ore by reduction with carbon. Iron extracted in this way contains many impurities and is called pig iron. Pig iron is granular and brittle. Its melting point is about 1180 degrees Celsius. For this reason, it is also called cast iron. To recall the important terms, here are the words to remember.